Welcome to This Explainer, everyone. Have you ever wondered if there's a way to actually spot those invisible struggles in your students before they even happen? Like, what if we could use machine learning, not just to grade what they did in the past, but to actually predict and prevent future failure? Today, we're exploring exactly that. We're looking at predictive model performance in education, taking all this complex data and turning it into real, actionable interventions.
Okay, let's dive into this. 30%. Think about that number for a second. A real EdTech company recently applied a learner dropout prediction model, and they managed to reduce their student dropout rates by a massive 30%. That is literally nearly a third of at-risk students who would have just slipped through the cracks, right? But instead, they were supported and guided to success. It's about fundamentally changing student trajectories, and it's a real game changer.
And honestly, this brings us to the ultimate dilemma for pretty much any educator. Which learner will struggle? Usually, we only find out after a student bombs a test or just stops logging in. But by that point, the damage is already done. So our goal today is to answer this question proactively. We're going to use data to give us a window right into the future of our students' learning paths.
So here is our roadmap for the explainer today. First, we'll look at the paradigm shift. Second, supervised learning and pre-processing. Third, feature engineering. Fourth, the AI Studio workflow. And finally, validation and optimization. Let's get right into it.
Section 1. The paradigm shift. We are moving from post-evaluation to proactive prediction.
Moving right along to Section 2, supervised learning and pre-processing. These are absolutely crucial, the core principles of AI prediction. And this brilliantly illustrates how it all works. If we want to proactively predict outcomes, we really need to understand how the AI learns in the first place. Supervised learning, which is exactly what we use for predicting dropouts, relies on historical data with super clear labels. Think tags like, "This student succeeded," or "This student dropped out." The AI basically learns the rules of what leads to success or failure. This is completely different from unsupervised learning, which just kind of analyzes raw data to find hidden patterns without any labels at all. Because education gives us very specific historical outcomes, supervised learning is definitely our best approach here.
But, as you probably know, educational data is incredibly messy. Think of it like cooking, right? You can't just throw a bunch of unwashed, unpeeled vegetables into a pot and expect a Michelin star meal. You've got to prep your ingredients. In data science, this pre-processing stage tackles three massive challenges. First up is imbalanced data. Look, most learners succeed, so the few failures can actually confuse the AI. Second, missing values, from skipped quizzes or half-empty student profiles. And third, high noise, where random external factors totally skew a score. We absolutely must clean this data before the AI can learn a single thing.
Which leads us to Section 3, feature engineering. This is all about crafting meaningful indicators from that raw data.
See, this is where it gets really fascinating. Technical logs can become deeply human indicators. Take a simple raw data point like a quiz retry count. Educationally, that translates directly to a learner's persistence and their attitude. Or let's look at a very specific language example, tracking exactly when a student masters the difference between the Korean topic particles in nun and iga. Tracking the actual speed of this specific grammar acquisition, it turns out to be a massive predictor of their future success. We aren't just blindly feeding numbers into a machine here, we're feeding it translated human behaviors.
All right, Section 4, the AI Studio workflow. This is where we get into accessible, no-code model development. Let's move to and see how this builds, because you really don't need to be a software engineering genius to put this together. Thanks to platforms like Google AI Studio, this entire workflow is a highly accessible no-code process. First up is problem definition. We just defined exactly what we want to predict. Second is the data split. This is super important. We divide our data, 70% to train the model, 15% to validate, and 15% to test it. We keep that test data completely hidden from the AI to prevent it from just, memorizing the answers. Third, we upload our pre-processed data. And finally, step 4, we initiate AutoML training, which basically allows the system to automatically hunt down the absolute best predictive model for us. So easy, right?
And that brings us to our final section, Section 5, validation and optimization. Let's talk about evaluating the results meaningfully.
Once the model is finally out of the oven and trained, you'll find that standard computer science metrics don't always align with what educators actually need. So, imagine a sample of 100 learners where 10 of them actually drop out. Let's say our model successfully catches 9 of them. The overall accuracy might technically be 94%, which, hey, sounds amazing, but in education, we care way more about the recall metric, actually catching those 9 out of 10 at-risk students. So the crucial point is, finding the specific students who need our help is vastly more important than just having a perfectly neat accuracy score.
To really understand why overall accuracy can be so deceptive, just think back to our imbalanced data challenge. If 90% of your students naturally succeed anyway, an incredibly lazy AI could literally just predict everyone will succeed 100% of the time. And you know what? That completely useless AI would technically be 90% accurate, but it would have a 0% recall because it missed every single actual dropout. We have to optimize our model for finding the needle in the haystack.
And to make the model better at finding those specific students, we use some neat optimization techniques. First, we handle that data imbalance through oversampling, basically artificially amplifying those failing student profiles so the AI is forced to pay closer attention to them. Next, we use hyperparameter tuning to fine-tune the algorithm settings under the hood. And most importantly, we use SHAP values to pry open the black box of AI. If the model flags a student, SHAP tells us exactly why. Maybe it was a sudden drop in login duration, and that gives a teacher exactly the context they need to step in and help.
So, we've collected the data, trained the model, and successfully predicted the dropout. Awesome! But now, how do we intervene without bias? Machine learning is, at the end of the day, merely a tool. It's like a highly sophisticated flashlight that just highlights where human educators need to look. We have to make absolutely sure our interventions don't stigmatize the learner, but instead offer them a customized bridge to success. Because the entire purpose of predicting these outcomes is just to give one more learner a better chance. So I'll leave you with this. What kind of proactive safety net will you build for your learners?